A culture initially contains 1,500 bacteria and doubles every 30 minutes. Find a function that models the number of bacteria, n of t, after t minutes. Find the number of bacteria after 2 hours, and after how many minutes will the culture contain 4,000 bacteria? We're going to continue to use the relationship n of t equals n naught times t to the RT power. Here we know what n naught is. It started off with 1,500 bacteria, but we don't know what the relative growth rate is. We can figure this out by using the scenario that it doubles after every 30 minutes. So after 30 minutes, we're going to have 3,000 bacteria. So 3,000 equals 1,500 times e to the r times 30, because we know it doubles after 30 minutes. If we divide both sides by 1,500, we get 2 equals e to the 30r power, and then we can rewrite this in logarithmic form. This gives us ln of 2 equals 30r, and dividing both sides by 30 tells us that r equals ln of 2 over 30, and this is approximately equal to 0.0231, which means we have a relative growth rate of 2.31%. Plugging this in gives us our function n of t equals 1,500 times e to the 0.231 t power. So this is our function. Next, we're asked to find the number of bacteria after 2 hours. We know that 2 hours represents 120 minutes, so we just need to evaluate n at 120, which gives us 1,500 times e to the 0.231 times 120 power, which is approximately equal to 24,000 bacteria. So that tells us how many we'll have after 2 hours. And we know that's the case because it doubles every 30 minutes. So if it started out with 1,500, after 30 minutes it doubles, so we've got 3,000. After another 30 minutes it doubles, we've got 6,000. After another 30 minutes it doubles, we've got 12,000. And then after another 30 minutes, we're at 2 hours, it doubles, and we're at 24,000. Now, the other question will take just a little bit more work. After how many minutes will the culture contain 4,000 bacteria? In this case, 4,000 is our function value, and we need to solve 4,000 equals 1,500 times e to the 0.231 t power. To get the exponential expression alone, we divide both sides by 1,500. So we've got 4,000 over 1,500 equals e to the 0.231 t. We can simplify this fraction. We can get rid of 2 zeros on the top and bottom, and then 40/15 reduces by 5 to give us 8/3. So we have 8/3 equals e to the 0.231 t. If we write this in logarithmic form, we get ln of 8/3 equals 0.231 t. And dividing by that decimal tells us that t is ln of 8/3 divided by 0.231. And we can see with a calculator that this is approximately equal to 42.46. So the bacteria will be at a population of 4,000 after about 42 minutes. And that is our final answer.